and it was approximate because it wasn't exact. Well, there you go. Yeah, true. Okay, so if we were to look at this one, hold on, let me make it a better picture. Let's say we're doing it over more area. Okay, that's nice. We'll say we're doing the entire sine curve. Question, right now, n equals what? 4, right? 5. How come? Because it starts at 0 and it's from the left or from the right? From the left. So at the 0, left would be 0, right? So we have 0 and then we have another one, another one, another one, another one. So we have n equals 5. Question, what happens as n increases?
You get more triangles. Rectangles.
Ooh, the rectangles get smaller, and as the rectangles get smaller, I'm only at 50. If we kept going, if as I approach infinity, that's the whole idea of an integral, right? It takes in between a certain region of a certain function. So I have a certain function, I'll go to n equals 0. I have a certain function, sine of x. I'm going in between 0 and 2 pi-ish, right? An integral says, hey, give me something like an area formula of a rectangle, which would be height f of x integrand. What's this represented by again? Base. Change in x equals dx. And what does an integral do? An integral says, hey, that's your base, cool. I'm going to make it infinitesimally thin, and I'm going to accumulate it over the area, right? That's what an integral does. Okay, now we're doing what? Volumes. Why do they have the same color? That's gross. Hold on, give me a second. Let's make that, and then we'll do, there we go. And then let's make him something else. It's too similar. Different enough?
Yellow.
Okay. Can you guys see? Hold on, where is it? Okay, what am I actually trying to find the volume of?
The circle.
The circle, right? The sphere. Do you see the sphere? I'm actually trying to, here, I'll move them up a little bit. Okay, we're actually trying to find the volume of the sphere, right? Okay, but what's the best way, if we weren't using the actual volume of the sphere formula, what's the best way we could do? We could do a cylinder? That's kind of lame. Anyway, it's one big fat disk. What? What happens as I make it into 2 disks, or 10 disks, or 100 disks, or 1,000 disks? What's going on as I make those disks become thinner and thinner and thinner and thinner and thinner? What's going on, kiddos? It's getting closer and closer and closer to the actual volume. That's what the integration does of an area formula. It says, hey, give me disks. All right, cool, I can do disks. But right now, this would be an approximation, true?
Right.
But what does the integral do? It says, hey, let me make them infinitesimally thin. Question, guys, would this be dx or dy?
dy.
dy, why? Because the thickness of the disks is a change in y, right? If it's oriented that way. And so, like if the y is here and the x is there. So therefore, the integral says, hey, I'm going to accumulate it between the bounds you give me, the y top bound, the y bottom bound. I'm going to make them infinitesimally thin and find the volume, right? Now, we could have all kinds of different sorts of things for our cross sections. We could have, this is my area, this is my bottom, popping up on out. I could have circles popping up. I could have, oh, why aren't you working here? You're frozen. So sad I was on a roll. That's cool. Oh, there we go. Hold on, we're back. Okay, I could have squares popping up. I could have triangles popping up. I could have mixed popping up. I could have all sorts of things popping up. This one's the coolest one. Where is this, guys? Where is that? In this shape right now? Bottom, right? So if I was to look on the bottom, I can see that curve, right? So that bottom is, right? That bottom is the area between these two curves, and then what are the cross sections doing? They're coming up, out. What are my cross sections right now?
Squares.
Squares, right? And so what I'm doing, what the integral does is say, hey, don't worry about how things are going to be changing and changing sizes, how you're going to have little squares here, big squares here. It says just give me the boundary which we do by top minus bottom. Give me the area formula, because I'll take that boundary as a side, I'll then make an area, and then I'll accumulate it infinitesimally thin over. That's what cross sections does, right? Now what are we on? Axis of revolution. What is stuff doing? Revolving. Oh, I lost it. ¿Dónde está? Aquí? No.
No.
Lower, 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 lower. Aha! So now what's going on? Well, every time you revolve, what's your cross section going to be?
Circle.
A circle. And if we were to do it like geometrically, we would have to have little baby discs, right?
Yeah.
And with our little baby discs, There we go. With our little baby disc, we would have guys, would this be dx or dy right now? Because I'm revolving around, so my thickness would be, they don't actually show the thickness in this demonstration, but the thickness would be dx. Good. So my integral is making it infinitesimally thin, accumulating across, and I don't have to worry about, hey, sometimes it's bigger and sometimes it's smaller. My integral says, I don't care, just give me the boundaries, give me the area formula, and I'll accumulate and find you the entire volume. If you can figure out the radius, and if you can figure out the area, then boom, plug it into me and I'll find it for you. Cool deal? So then we were solving yesterday. Look at all these cool things I couldn't show you. And we got to our first rubber card in section 7.2. We already did one for cross sections, which I guess was 7.2a. 7.2b, we have our discs. Some of you want to visualize a lot. Some of you want to visualize a little. I don't care as long as you understand and are getting it. Danny, careful, I've made 3 people stand today. Eyes up here, not your business. Thank you. Okay, I don't care as long as you're understanding and getting it right. Okay? If you need to visualize, visualize. If you don't need to visualize, don't, but don't make a mistake. We talked about how thickness dx, right, thickness dy. We want to get to some interesting examples today. Here's a fun one.
Yes.
Showing you what it means to be a solid generated about. Because we have a 2-dimensional curve, right? But as soon as I rotate, the solid generated, for those of you that couldn't picture that very well. We're going to go to Calc 2 for just a second. Sorry, Calc 2, if we're doing surface area, you have to find arc length and do little bands around. We're not going to do that, don't worry. That's fine, surface area. We don't have to do that. But we are going to take slices. Wait, we can't do that and have it all crooked, but what we can do is make it normal like we could do and have the integral make it infinitesimally thin. Anyway, that's what we're doing.
Replay.
No, we're done. Okay, that was discs. Question, why was this a disc?
Because you can't stick your hand.
What's the word I use? It's flush with the axis. Hold on. Just because it's flush with some axis? What's so important about the axis that it's flush with? Has to be the axis of revolution. Right? It's flush. It's all the way, it's perfectly against. So if this thing was spinning, you guys just saw that, right? It was and it spun and it had a solid of revolution that was generated. Could I have stuck my hand in that thing?
No.
No. And as it was spinning, it'd be bad if I did, right? Well, we're saying it's sharp. Okay, so it'd be bad. Right? Disc, meaning no big dealio. Cross section is going to be a circle. It's going to be a solid circle, so therefore pi r squared. How do I find r? Top, bottom. Why is it dx? Thickness is changing x. Disc or washer? Ooh, we didn't finish him. You guys there in your notes?
Washer.
Disc or washer?
Washer. Wait.
Who's over there? Benji, go sharpen this real quick. Sterling says please. Go quick. Why is it a disc or wait guys, I wrote disc, so I don't know why you're saying washer A. And B, give me a reason why. I'm just holding this. You came back. It's flush. What's flush? Wait, what am I revolving around? Is it perfectly against the entire time over the interval? Ooh, pause. Can you guys plug in? Go. I didn't finish yesterday. You guys finish now. Benji, come on, Ben.
Come on. Come on. Come on.
Okay. Danny, sorry, stand up, bud. Danny, come over here. Grab your notebook, grab your pencil. You're gonna stand up for the rest of class. It's not comfortable, but it's effective. Okay, you guys should be plugging in. Why is it dy again?
Revolving around the
Okay, some people might be memorizing. It's revolving about a vertical axis that you can memorize that, or the thickness is change in y. Not the same.
No.
Okay, change in y. What are my bounds? 0 to I don't know. You're looking the wrong way. Y bounds. Little slash marks, little hash marks on. I said it right. Little hash marks on the axis, right? What is it? No, hash marks. Trying to confuse me. 0 to 2, right?
Yeah.
What else do I need?
The function.
The function. Wait, we're forgetting something kind of important. Starts with a P and ends with an I. There you go. Pi. And we just celebrated him, you guys. Horrible. Little guy. Now I need the function. Wait. Don't say that. I don't need the function. I need the radius. Right?
Yes.
Okay. So I need the radius. Why? Because it's pi what?
Squared.
So I need the function technically of the radius. You can think about it as r of y. What would my radius be? Function minus 0. Why? Because this one's x equals 0, right, on this side of my radius. And then the other one is y minus 3 over negative 2. That's kind of gross. Let's make it 3 minus y over 2. That's prettier. There we go. So my radius is, of course, minus 0. We don't need to worry about. If any of you are like, why are we writing the minus 0? Just hold on. And then, why am I about to put a dot, dot, dot?
Because we can solve.
But actually, I'm not going to put a dot, dot, dot. Hold on. Someone asked a question in period 1, and it was a great question. Wait, did I ever start recording? I did, right? I think. Is my microphone on? Hold on. Jezreel?
Why did the signs change?
I did. There's a, wrong button. There's a negative. So what did I do? I brought the negative and I put them up and I was like, hey, whoosh, whoosh. I brought the negative up and I said negative y, positive 3. Okay. Kiddos, real quick, how would you solve this integral by hand? Wait, what? They would make you do that? Yes, why? Are the intersections decimals? No. So the AP guys say you can solve. How? What would you do? You could do use them. Could I pull out a 1/4 just to make life easier? Wait, what? How?
Squared.
2 is squared, so it's over 4. Okay, some of you would pull out a 2, and I know you would.
Genius.
Some of you would pull out a 1/2. It's better, but still not right. 1/4, right? What's still left inside?
3 minus y squared.
Right now, you have 2 options. One is FOIL and power rule. The other one is U sub. There is no other option. If you go straight to 3 minus y cubed over 3, you're wrong.
You sub.
Okay, so U sub. 3 minus y. Why is it so stinking important to actually do it and not just imagine it? Because, guys, what's du dy? Ooh. My ones who started thinking, hey, shortcuts, I can skip. Right? You're going to kill bunnies, I promise, at some point. Most of you. So, coming back. Now what? Yeah, now I can say that dy is equal to? Negative du, so I can do u sub and say, hey, from 0 to 2, I'll come back to that. U squared, du, pull out a negative 1. Wait, volume can't be negative, hang in there. Then if I go ahead and say, I want bounds, my ones who didn't know what u bounds were. How do I find u bounds? Plug in 0, plug in 2 to u, right? So if my u bounds are found by plugging in, there's my top, there's my bottom, I plug in, 3 minus 2, 1. 3 minus 0, 3. Oh, that's why there's a negative. No. Because the bounds are flipped. But I could then go ahead and flip the bounds again and make it a negative, which makes it a positive, all better, from 1 to 3 of u squared du, which of course would be 1/4 pi. You guys don't need to see this, I know. But there were so many places in your homework, in your work, where there is illegal math going on all over. Just be careful, okay? Now plug and chug. Do I have to go back to y's? Nope. It's going to be 27 over 3, 9. And it's going to be 1 over 3. 9 minus a third. Ew. 26 thirds? Over 12. 26 twelfths? 26 twelfths would be 13 sixths? I think. That's the worst way to ever do math, but I'm trying to move on. Does anybody back up the math?
Yeah.
27 thirds, that'd be 9, right? Minus 1/3 would be 26 thirds, 26 thirds, 26 twelfths, 26 twelfths, 13 sixths, right?
Yes.
Thanks. Moving on. Ooh. Wait, wait, hold on, go back. We only did discs, but we saw something else yesterday.
Oh, washer.
What's different between a disc and the washer?
The washer is not flush.
I have a hole and a hollow. Now hold on, let me make this a little bit more accurate because some of you were like, ooh, that was really bad demonstration yesterday. I know, I apologize. Because technically, isn't this kind of like a plateau, a flat top? Hold on. There we go. It's a plateau. There we go. That's a little bit more accurate, right? Because technically it doesn't come all the way to a point. So therefore that's a little bit better. Let's go ahead and put a minus. Why am I subtracting? Because if I was in woodshop and I was making it, I would make the solid and then I'd hollow out. True? Mr. Shanks came in and said, I forgot all this, but woodshop. I was like, yes. So, coming back. He was excited.
Wow.
Oh.
I have that recorded in advance.
Oh.
That's rude, Nick.
Grace, it happens, right? Every now and then something just...
David.
Okay, shh.
But for niggas, all the
Don't return rudeness for rudeness. Life lesson. Come back. So, now what? Now we can do the next notes. Did we already take this down yesterday? Wait, not that. This? Oh. All right, come back just 1 second. Question, why was it a washer?
Why is it hollow?
Focus. Why is it a washer?
Why is it hollow?
The why is the problem. There's a hole in the middle. And it's not flush with the axis. Look at all that empty space. If I put my hand in there and it's spinning around, am I good?
Yeah.
Yeah, as long as my hand's not too fat. Okay, there we go. Stick it in, I'm good, right? Wow.
We're excited.
You're excited.
Yeah.
Question, why did I not just say subtract? Radius equals top minus bottom, right? No big deal. But integration is defined to be, when I plug into an integral, right? When I plug into an integral, it's defined to go from the top function to, if it's dx, the horizontal axis, and if it's to the y, it's going to be, if it's dy, it's to the y-axis. So when I plug in this function, and when I subtract, when I do this minus this, in some ways it worked before because area of the region, I just need to figure out this length minus this length, and I got my area. But in this case, I need to plug in a radius, and when I plug in a radius, guys, I need to have the whole solid with a radius that goes from the very, very outermost to the axis of revolution, whatever it may be. That's not really very visible, I apologize. To the axis of revolution, whatever it may be. And I need to then go ahead and have, for the hollow, from the outermost of the hollow to the axis of revolution, whatever it may be, pretend it's in the middle, I apologize, in order to be able to have my whole minus my hollow. If I just go subtracting, I'm making a whole brand new shape that doesn't even correspond like you think it would to this one. So I have to do them completely separately. What's the whole thing minus? Let's take out the hollow. So we are now talking about figures that are not flush with the axis of revolution. Some of you guys are looking at this and reading it. Something is different beyond a washer. Something is different beyond a washer. What? Come back. What's different beyond a washer? Where am I rotating? Tanner, louder.
You have a different axis.
I have a different axis of revolution than what?
The
The axes, right? I've been revolving around the x, I've been revolving around the y. Is that all I can do? Psh, no. I can revolve around any y equals or any x equals. Question, is it going to be dx or dy? Dx or dy? Why? You could memorize it's around a horizontal axis, or you could visually think, hey, if I were to go ahead and have it circle, whoosh, I can't draw on these, I forgot. If I was to go ahead and have it circle, hold on, give me 1 second. And if I was to cut that circle into,
What? No.
if I was to make discs out of this, right? If I was to make discs, question, what would their thickness be? Yep. If I was to slice it and pull it, whoosh, it would have a thickness of x, change in x, right? So I need dx so that my integral can make them infinitesimally thin and make it nice and smooth, right? There we go. But how do I do it? How do I do it? Well, question, kiddos. If I was thinking about whole thing, am I even looking at this part where I can stick my hand in and I'm safe? No. I'm looking at the whole thing. Question, what would be the outermost? Right here, right? Radius, I only have to go from the outermost to the middle to the axis. Wait, which axis? To the x-axis?
No.
It's not going to be minus 0. What's it going to be minus?
Y equals 1. Negative 1.
Minus negative 1, aka plus 1, true?
Yes.
So I'm going to go from the outermost function, f of x, whoever he is. We'll say he's f, he's g. Why? Because he's on top. I don't know. So he's f, right? So I'm going to say my radius is going to equal f of x, is in terms of x, because there's a thickness of dx, f of x minus negative 1. That would be the radius that goes in, pi r squared for the whole. Minus, I need the hollow, so I need pi r squared. What's the r of the hollow? Not f, but g. Minus 0? Nope, g minus
1.
negative 1. Careful, 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 wherever you're revolving. We'll come back to that in a second. Let's go back to our notes and write down stuff about washers. Can you read it?
Yes.
Good. Go. If you want drawing tips, I drew it a little bit differently on the board. Same basic idea.
Alright, 15.
I'm not going to draw it all over again, though. Kenny.
So if it was like x squared or something, so would it be like...
As the axis or as the function revolving?
The function revolving.
If it was x squared,
Yes, or something like that.
depends what you're revolving around. If you're revolving around the y, like a paraboloid from last year, your circles revolving around, remember, show your revolution. Your circles will be going this way, which means your discs will have a thickness of this way, so it'd be dy. If it was just x squared, it's centered at the axis, so if it was revolving around the axis, it would be the right one, so in terms of y. Kenny, I think I'm getting too deep in words and not being able to visualize. Let's wait until some more examples. Maybe you still have it after Andrew. Forever, number 40. 8, which is really our 49, because we have an A, which I forgot, but you guys reminded. Thank you. 48. Ooh. Keep going, get it down. I want to do some more examples. I'm going to zoom in for a second. I'm distinguishing between, hold on. These axes, if you guys can tell, are a little bit off. Let me fix this first. It's in the center, right? I'm going to show it this way, Di. Whole top, whole bottom, axis of revolution. That gets me my whole radius. Hollow top to hollow bottom gets me my hollow radius. So then I can go ahead and plug those in. To say radius is the whole top minus the whole bottom. And the hollow top minus the hollow bottom.
Pi.
I have to go from the outermost to the axis and then the outermost to the axis. So I have the entire thing and I have of the hollow thing. So I have two different radiuses. I have one here and I have one here. Big R. This one. I use green on both of them. So guys, even though I can simplify it in one big integral, it's still, in essence, two separate areas. You get the big thing, you hollow out, you get the whole circle, or the whole disc, you pull out the hollow. The integral says, hey, no problem, give me the boundaries and I can do it throughout the entire region, whether it's changing, et cetera, just as long as you give me the boundaries, and then tell me when to start, when to stop for my bounds. And I'll make them infinitesimally thin and accumulate them all. Jezreel, cheering for calculus. Nick.
Right above the spectrum,
Mhm.
double function with the general. I thought you said, when I asked you the other day, I thought you said you couldn't do that.
Couldn't do
It had to be two separate things.
So, even though I can write it as one big integral, I'm still doing it separately because I have a pi big R squared minus a pi little r squared. The point is, I don't have a pi big R minus little r quantity squared. That's illegal.
Oh, yeah, no, I wasn't.
But I can split that up in two
Yeah,
integrals.
that's what I meant.
Oh, it didn't come across. I apologize.
Is the other bounds x sub 2x sub
Yep. Or you could put A and B if you want. I put like A and B and C and D. Can I zoom in on the forever? Are we all done drawing?
Yeah.
No.
Yeah. Oh, man.
Are we almost done drawing?
Just right
You
there.
can see most of it. Remember, always show that indicator of where you're revolving. Just because, I don't know. In my mind, I'm like, hey, disk, and I can think, hey, thickness, dx. I don't know. That's me, though. Maybe it's not you. Could just memorize again, horizontal axis is going to be dx, vertical axis is going to be dy. But as you guys just saw a second ago, that's not necessarily the x-axis and the y-axis. Could be x equals another number, that'd be vertical. Y equals another number, that'd be vertical. Couple more seconds.
I asked Russell to please move his head and he was.
Move your head.
Bird.
Okay, ready?
Yeah.
No!
A little bit longer.
Thank you.
You're welcome. Thank you for saying thank you. Do you guys feel a forever quiz coming?
No!
Well, I get the last one. I don't think. Wait, how many?
What's today, Wednesday? Kind of, unless you need to review it on someone. This is 49, so I have one extra. Now the crazy thing is, my next example. Yay, we already did. Okay, so instead of that next example, let's do another next example. Ready? Following. I made this one up this morning and it worked pretty well. Find the This looks a lot like an AP question. Why? Because there's no picture. And no calculator.
No.
Why? Because they're basic graphs. You don't need a calculator. Intersections are whole numbers. Psh, you don't need a calculator. Alright, cool kids. Let me give you 120 seconds to see how far you can get. If you like visualizing, I would start graphing. If you don't like visualizing, start plugging. But these are very careful, maybe visualize too. What can you do? I threw in a couple interesting things.
Is optimization going to be on our final?
Final as in?
As in the AP final that you're going to take as a final?
Of course. Maximize, minimize, find the max, the min, that's critical numbers. Pitchfork.
Oh, I didn't know.
Bless you, bless you.
The pre-cal version of probably isn't. But there will be clues you have to go looking for, so I guess it will be.
That's where I got it.
Just thought of it.
Oh, okay.
By attempting, no one will get an F.
Better than it.
No, the region bounded by in the first quadrant. He's gonna ask where you're typing. That's like I can't say it's a secret. Got it. Here we go. What do you guys got? How many of you guys visualize somewhat, either drawing or in your head? Really? That's serious? Uh-oh, I'm scared. All right.
Wait, that we visualized?
No, that over half the class didn't visualize in their head or on paper. That's a little scary. Okay. I'm going to visualize because it helps me. I have a graph. I have an x cubed, true?
Yeah.
And I have a what?
Yeah.
Uh-huh. Does y equal x and x cubed intersect at all?
Yeah.
Where?
1 and 0. Oh, wait, maybe negative 1?
What can I totally not pay attention to anymore?
1, 1.
1, 1? No, I need to pay attention to 1, 1. What do I not need to pay attention to? Why not -1, -1? What do I say about the area bounded? In the... Alright, so let's get rid of the rest. If you're helping someone, whisper. Okay, in between... Hold on. First quadrant. Oh, I still didn't draw. What didn't I draw yet?
X equals -4.
Okay. Good. Right? Question, just by looking at it. Disc or washer? Yeah, how come? Is he flush with any horizontal or vertical anything? No, it's not going to work. Where is he revolving around? X equal... What? Are you serious? Yep, serious. There he is. How's that going to go?
It's going to be a bowl.
It is going to be a bowl, kind of. If I were to visualize even more, which you don't necessarily need to do, but I could go ahead and, what, he's 2 away, right? So now he's 2 away over here. He's going to come around, right? And then he's going to come around. And then he's going to come around. And he's going to come around. And then there's going to be like this little derp over here. And technically this little derp is going to be going all the way around, but guys, can I stick my hand in and be safe? Yeah. Totally. Hold on. Wait. What have we not shown yet? Good. Question. Dx or dy and why?
dy. Because it's a vertical axis.
There's no names. There's no at once or closing. Fine. Is that closing? Yay! Executive decision. Okay, so come back. Sorry, I was thrown off. Why dy?
Because it's a vertical axis.
If you want, don't even worry about messing up your picture. Just say, hey, if he's going this way, what is he? Ta-da! Dy. Okay, cool. So I have dy. I have a washer. Uh-oh, which means I need whole minus hollow. Right, cool kids? So if I need whole minus hollow, technically I'm going to put them in one humongous integral because whatever I can. I can pull a pi out of everything, but just to be safe, I won't. Question. I know it's dy. Okay. What are my bounds? -4 to 0.
Oh, no.
Almost if I was doing x's. Think about it a different way. Don't think this away. Think this away. Careful. If it was this away, you wouldn't have gone far enough, right? Because you wouldn't have to keep going. But the nice thing is dy. I'm accumulating these little weird washer thingamabobs. That's all hollow. He's going to be solid. Right? Remember, I have to tell these tell the integration, or in the integration will result in the exact right size of disk, right? This shows dy, but the y equals shows the cutoff. So I need to cut off where and where? 0 and 1. Does that make sense? Now, cross section. Circle. Oh yeah, I knew that. I need pi big R squared, pi little r squared, right? My big R, my little r. Boop. I need the whole, and I need the hollow. Question. Radius. I'm going to change colors just for a second, just so we can be clear. The whole radius. I need to go from where to where? Where's the center of the circle? The axis of revolution, right? And I need to go for the whole thing, I need to go to the outermost, which would be what? Which function? Right? Okay, hold on. So my big R, here he is, goes from the axis to, how do I write that down here? Well, I have the integral. How do I fill them in? What is big R? Cubed root of y? Whoa, what's going on? Minus -2. Hold on, y. What am I in terms of? Oh, stink. They were tricking me. X equals the cubed root of y. Okay, that needs to change. And what else needs to change? Y equals x. Okay, he's not as hard. So, what was the outermost of big R? Cubed root of y. Not the outermost, that's the cubed root, right? So the outermost was the cubed root, right minus left, cubed root minus -2. Why -2 and not 0? Because I'm not going to 0. I'm going here to my axis. Then cool kids, what should be the hollow? Got it. Still -2. But I'm not going all the way. I'm going to x equals y. So I'm going to have y minus -2. Booyah! Now what? Be careful. Okay. Questions? Okay. Why do I need to do what? Subtract -2 because how do I get this distance? If I just go cubed root of y, it's only going to go to 0. But if I go minus -2, now it's going to take cubed root of y plus 2, ta-da, radius. Does that make sense? Guys, it's still 35 seconds. Man.
Oh.
What's my ... for?
All the work that should be shown that you.
All the work that should be shown in solving, right? Now, this one might be a plug in and solve because I'm pretty sure it's a decimal answer. But the pi's definitely can come out. You can solve it separately. You can solve it together. It just has to be, remember, whole pi r squared minus hollow pi r squared. Kiddos, with that, we are at more illustrations or examples in case you want to see and learn more about it. Yes, but that's up to you. Otherwise, you have my videos online and you have homework. I even told you discs. I told you washers. And what has everything mixed? 18 number 13. Get out of here, kiddos. I feel